Hi there and welcome back. Today we've got a huge day of configuring the Nissan R35. Davo's done an awesome job wiring it, so now it's up to me to set up all the inputs and outputs, configure all of the sensors, set up the engine triggering system and try and get the thing running. So you might ask why I'm standing here. Well, I'm doing it wirelessly because I can and because it is a fairly cramped driving space. But today, I'll be doing as much configuring as I can on the bench here. Then I'm gonna jump in the car, I'll press some of the buttons, I'm gonna test the PDM functionality and see how much current each of the functions in the car draws, so I can set up all of my current limits, all my soft start stuff for my thermo fans and for fuel pumps and stuff like that. So let's get into it, I've got plenty of stuff to do. So the first thing that we're gonna do is plug our USB cable straight into my laptop. I know I said it's Wi-Fi, but we do need to set the Wi-Fi password in order to use that functionality. So now that I've plugged my USB cable straight in, the power from my laptop will actually power the comms inside the ECU. So I don't even need to turn the ignition on in the car. All I've done is plugged it in. I'll open the software. It's loading now. It's pulling all of the data out of the NEXUS ECU and I'm online right now. And if I go for connections, Wi-Fi, okay, here we go. Wi-Fi, if I turn it on, the SSID, so just like your home Wi-Fi, we've got the name and password. On this car, I've made it R35 GTR as the name. The password is 123456789 So not too hard to guess, but at the same time, I'm sure that'll change once this thing's on the racetrack and the owner's got his car back. For your own car, we've got all the same security as your normal Wi-Fi at home. So things are pretty secure and the odds of someone actually hacking into your car to change anything, probably fairly slim, I would imagine. So now that we've set that Wi-Fi communication up, I can take the USB cable out and I can just communicate via Wi-Fi and get the thing configured and up and running. All right, the moment of truth. Don't worry, I have practiced this off camera, so I know that we're not gonna let all the smoke out when we flick the ignition switch. There we go. She's powered up. Wow. So we've got the Haltech IC7 dash in the middle. That's got one CAN cable connected to it. It's got that CAN cable loops across to the CAN keypad that's got 15 channels. Then the CAN communications from that loops across into the ECU. That's all the wiring that's been done behind the dash in this thing. So it's so beautiful in the way that if you had a whole bunch of gauges here, all that's gone now. You just plug a CAN cable into a dash and it gets all the information directly out of the ECU. Likewise with the keypad, this is something that's new to us and we're super excited about it because the wiring complexity that this cut down in this project, there's days and days of work in wiring all of the switches and making it all neat and doing all of the testing. Whereas the way that we've got this, it's not actually configured just yet. We're going to go through that and do that now. But we've put all the stickers on because we know what we want all of the buttons to do. Then instead of having to wire, for example, this to the turn signal, so to one of the indicators, this to another indicator, this button through a relay to a thermofan, the fuel pump override buttons to sort of have to splice into the triggers that normally would come from the ECU, we can just program all of these buttons to act as on-off switches, press button, what we call momentary, so only working when we actually press the button, or latching, meaning that you press it once, that latches on, you press it again, it latches off, or depending on the function, like headlights for example, you could press 1 for parkers, press it second to turn on the normal headlights, press it the third time, and then everything turns off. So the keypad functionality in here is a huge advantage. It makes all of the wiring so much easier, you save so much time and money. I can't wait to configure it and I can't wait to set it up and to actually see it working. The beauty of the keypad is that it's so much more than just a bunch of switches because it's also in a way like a dash or an error display. And what I mean by that is that when you press one of these buttons, there's a bunch of lights. There's 3 lights along the top of that button and they're actually reporting back to us a bunch of information. So let me use the thermofan one for example. If I press the button, it does have like a tactile feel, so I can almost feel like the click, so I know that I've pushed it. But the first light is showing me that I have pushed that button so that I know what's going on. The second light is telling me that whatever that's controlling, so that fan for example, the fan is actually on. So it detects if the fan's turned on, comes back, turns that light on, so I can actually see what's happening from inside the car. The third light is an error light. So if it goes over current or something happens, the error light turns on. So from the driver's seat, without having anything to do with my actual IC7 dash, I can still see a whole bunch of error states over here on the keypad. Such a handy thing to have. Secondly, this is 15 inputs into the ECU that you don't need to wire and you don't need to chew up on the engine management system. So if you've got a car that's heavy, really, really heavy on inputs, like this car is, having all of these buttons like indicators, high beams, thermofan overrides, fuel pump overrides, power steering overrides, anti-lag buttons, traction control enable buttons, even the start-stop button to control the starter motor. It's a bunch of inputs that otherwise we would have had to come up with fancy ways to get that to happen. But because this stuff all goes in via CAN, as much information goes in as we can get, and that's it, it's done. Also, it reduces the number of wires in the car. So if you are weight conscious or if you're using some really nice Tefcell wire, it also cuts down the wiring costs. In the past, to configure a keypad in a car like this, we would have had a standalone PDM, we would have had a standalone software package that would then make the dash, the PDM and the engine management system all communicate over this CAN network that we keep talking about. Now, things are a whole lot different. We plug in our NSP software into our engine management system. The engine management system is kind of the brain. Then the keypad plugs in, and all we need to do is go through our NSP software, and there's no more of this coding and C++ and all of this CAN protocol stuff. Instead of doing any of that, in our software, for our start-stop button, for example, I go into my stop-start function in the software, I choose start button, I go through and assign an input, and to assign that input, it could be a wired input, so a digital or analog input straight into the ECU through a wire, through a conventional button. Or if I scroll further down that list, I've got a keypad enabled, so it allows me to pick any one of these 15 buttons. So I pick this button, double click on it, and from now on, that's my start-stop button. If I messed it up, or if I want to change it, or maybe driver might be a little bit shorter than I am, so it might have to be on the right rather than on the left, all I'd need to do in the software is just reassign that button, double click, move it to this side, and that's the end of it. It's so simple and it's so elegant in the way that it works that it's going to revolutionize the whole way that you would set a car like this up. I've set up the Wi-Fi password, and what that means is I can get out of the cramped cabin, I can sit at the desk, and I can now go through and assign the inputs and outputs for all of the sensors. This thing's got a huge number of sensors on it, so I'm not going to bore you going through every single one of them. We'll go through and we'll configure oil pressure and fuel pressure. I want to go through the software and just show you how to configure those, then we'll move on to the transmission stuff. In order to configure the sensors, I'm just going to cruise on down here to the little tab that says Sensors. These are all the things that I've already got configured in this ECU. Like I said, I'm not going to go through and configure all of these. The video would take half a day. But what I am going to do, I'm going to cruise up here. I'm going to type in oil pressure. There's an oil pressure sensor. There's a couple of different ways to turn your sensors on and off. You can come into here and tick on or off just here to turn that sensor on. Or if I didn't want to do it like that, I may come oil pressure, come down to that oil pressure again. I can right click on it here, enable the oil pressure sensor. Alternatively, if you're used to the ESP software, up the very top of the page here, there's an F4, enable, disable. If I click on that, it brings me to a page here that's got all of the ECU features and functions. And if I cruise along all of those, find oil pressure, and you can turn it on there as well. So personal preference, which way you like. Personally, I like using the search feature, and then just coming down, it highlights that the sensor is red, telling me that there's an issue there. I cruise down further, it tells me that the issue is in the wiring, so when I click on that, oil pressure input, not assigned. So that's telling me that I haven't actually set this sensor up yet, and the ECU is telling me what I need to do. If I come down here and click on Edit, if I come across to Davo's wiring diagram here, I can see that he's assigned oil pressure to AVI 11, analog voltage input 11. I'll double click on that. There we go, we're away. If I come back up to oil pressure and have a look at the calibration, which is half to 4.5 volts, 0 to 150 psi. So this thing's using all of the Bosch pressure temp sensors, so it's pressure and temperature in one sensor. It's a really nice thing to have a look at. That's it, oil pressure is configured, no more work. The next job, fuel pressure. If I just come up here to exactly the same time, type in fuel pressure, I can see it there, it's greyed out, so it's not turned on yet. If I just click on it there, enable fuel pressure, yep. Already it comes up red down the bottom here. Wiring, fuel pressure input not assigned. Click on edit. Look at Davo's wiring diagram again. Fuel pressure AVI13. It's the last available input. You can actually click down, it's quite interesting here on the I/O report here. If I have a look at this, available connections. So this is my last analog input available in this particular configuration. But if I start scrolling down here, a little bit off topic, but if we start scrolling down here, these are our available analog inputs. This gives us all of the available channels that I could use for that oil pressure or that analog input. You can see that this thing's pretty full up. We'll click on AVI13, the one that it's wired to. Check the calibration, 0 to 150 psi, and that's it. Oil pressure and fuel pressure are set up. It's as simple as that. So now that we've got past the PDM setup, past the basic sensor setup, it's time to get into some of the NSP functions that I think are really cool. One of the nicest things about it is the automatic transmission control function. So I've already said that this car's got a sequential gearbox in it. It's a manually shifted 6-speed sequential with reverse. So I'm going to first go through and configure that using the gear position sensor, so the ECU knows what gear the gearbox is physically in, as well as the load cell gear knob, so that we can do our flat shifting, we can do our downshift, throttle blipping. All of this stuff is all closed loop, obviously. But then after that, we'll mess up this calibration a little bit, and I'm going to convert it over. I know that this guy down the track does want to turn it into like an air-shifted thing with the flappy paddles. So we'll go through and we'll configure that and make it so that it's a full automatically shifted sequential, air-shifted sequential gearbox. First, in this demonstration, for this car with the 6-speed sequential, we just cruise through and make sure that we've got all of our transmissions set up correctly. So the first thing, drive type. This is a rear-wheel drive car. There's no transaxle, there's no front drive at all. Full rear-wheel drive. Transmission type, we're calling this manual at the moment. We'll skip back to this in a second, but because this is a manually shifted car, we're going to call it manual for the time being. It's got 6 forward gears. Then down the side here in functions, these are all of the things that we could turn on to support or whatever the car needs. In this case, we need to know the gear detection, we need gear ratios configured, and we need the flat shift setup done. So I've turned those on. Then we'll come across to the fun bit. Transmission flat shift. Basically what happens with this, if you're not familiar with the flat shift sort of method, is that when you're cruising along with a sequential gearbox, you would go full throttle. There's a little load cell in the gear knob. So when you pull on the gear knob, the engine management system knows that you're pulling into the next gear. And instead of having to lift off the throttle to unload the gear set, the engine management system will actually cut power to the engine just for a split second so that it unloads the gears inside the gearbox, allowing it to shift into the next gear. If you don't unload a sequential gearbox, you could never be if you were strong enough to pull it out of gear, it would certainly do damage to that gearbox when you pull it into the next gear. So that's the whole sort of idea behind what a flat shift is. In our configuration here, we've got 2 types, closed loop or open loop flat shift. Closed loop means that the engine management system is looking at the position sensor in the gearbox. We know exactly when it's in gear and exactly when it's not. Because of that, that means that we can actually cut engine power when you're pulling on that load cell gear knob. We can cut engine power until it reaches the next gear, then we can put the power back in, and that gives you that perfect shift every time. The open loop method still works really well. It's just probably a little bit different to what we're talking about with the closed loop strategy, where this is when you don't have a position sensor on the gearbox. So when you pull on the load cell gear knob, instead of the engine management system being clever enough to cut power while you're between gears, we would need to configure the amount of time it takes between gears. So we might say, all right, we know that this driver takes 80 milliseconds with this gear knob and this gearbox in order to change gears. We'd map that across all of the gear changes, across all of the engine RPM. It does take a little longer to set it up in this configuration, so if you can, go for the closed loop option. We've got our max shift time. This is basically a timeout so that if the driver misses a gear or if something happens, the ECU doesn't keep that cut open there for a huge amount of time. The blockout, so in between gears, we're saying that for 0.8 of a second, you can't keep pulling on the gear stick. So this is a handy thing, or some people might refer to this as a debounce. This happens when the driver pulls on the gear stick and might accidentally pull on it or shake it again. And in that case, you'd almost get 2 cuts for no reason. Moving on, we give you a whole bunch of options as to how you want to cut the engine power on the gear shift and how you want that power to be reduced. So whether you want a fuel cut, an ignition retard, or any combination of all 3. So that's probably a bit further down the line in the tuning setup, which we will be doing on this car a bit later on. We've got all of our throttle blip on downshift stuff. So when that load cell gear knob detects that you're shifting back down through the gears, it'll actually open the dual electronic throttles and give you a blip in between gears to do a closed loop rev match. So what that means is that between gears, the throttle blades are going to open without me pressing the throttle pedal. They're going to bring the revs up based on our gear ratio to what we think the engine RPM should be in that lower gear. If it exceeds that, it'll actually hold a rev limit at that matched earlier RPM. I know that's a little bit confusing, but have a look, sort of think about it in the way that you would do your throttle blipping manually in a normal manual car. So if you're shifting from 4th to 3rd, the idea is that you would blip that throttle so that you match the revs, so that when you come from 4th at, say, 3,000 RPM to 3rd at 5,000 RPM, that it's nice and smooth. In this system, the engine management system is doing exactly that for you. If we cruise on down here into some of the more setup stuff, so we've first got cut percentage. Basically what this means is when we're cutting the power, how much of the power do we need to cut in order to achieve a gear shift? About 90% seems to be a fairly reasonable value to start with. How much ignition retard to apply when we're doing that cut, and then how to ramp that back in over time. We've got our torque reduction time. This is an interesting value. So what this one does is when we're pulling on the gear stick and we're in between gears, so when we go from 1st to 2nd, for example, or 2nd to 3rd, the engine management system cuts the engine power when the gear position sensor knows that we're not in a gear, so we're in between gears. When we detect that we're 100% in 3rd gear, it'll keep the power off for this amount of time, 10 milliseconds extra, just to make sure that we're absolutely solid and we're truly in that gear. The next one along is our recovery time. So this is the amount of time the engine management system takes in order to reintroduce any retarded ignition timing after the cut. This helps to avoid any coughs or bangs as the power's coming back on. The last couple we've got here, throttle blip amount, throttle blip duration. So this is mapped versus engine RPM and versus gear. Throttle blip amount is how wide we want the throttle bodies to open. Throttle blip duration, how long they should hold open for in between gears to do that blip that I was talking about. Lastly, like all of the menus in the Nexus, the wiring. We click through here, all it's asking it for is flat shift input, so that's asking us for the load cell gear knob input. Well, that's this car configured, but let's go back to our transmission control stuff because I do want to have a quick look through this and show you what we've been working on. The Nexus stuff does allow more than just manual transmission control. If I click on this little one here, have a look at this. So we do a whole bunch of generic automatic transmission controls for things like air-shifted sequentials, or some of the Ford gearboxes, the GM stuff, 4L60, 4L80E, the Toyota A340, or Elanco or the Liberty style drag racing gearboxes. So all of that stuff is there, fully supported. Let's go through, for example, and let's pick up something like a Toyota A340. Straight away, the software sort of prompts to tell me what I need to do. So I need to turn on our transmission control function. Once I turn on the transmission control function, it then goes through and it actually configures it for me and tells me what I need to be doing and what that gearbox needs. It also tells me what outputs I need. So for example, on the A340, it tells me that I need to high side drive a bunch of shift solenoids. It tells me about torque converter lockups. It talks me about all of our auto shift points. So when we're driving the car, we put it in D for drive on the Prindle stick, or the park, reverse, neutral, drive stick. Then if we're cruising along and we go from first to second, at what throttle position it'll change from first to second. So at full throttle, it might change at really high RPM or a higher road speed. We map out all of this stuff so that then when we're driving this car, it's full automatic transmission control. It really is amazing. It works really, really well. And we're looking forward to seeing more guys using a lot of the factory automatic transmissions. I could click through all of the transmission control stuff for ages, and we could talk about every individual gearbox that we support. But what might be a nicest thing, jump on our website, download the NSP software. You don't need a NEXUS ECU plugged in to use the software and to set up a base configuration. So you can download the software, you can sit at home and go through straight to transmission control, pick the gearbox that's already in your car or the one that you might be sort of thinking about putting in your car. You can go through and have a look at all the features and functions and the way that you need to control that gearbox before you go through and commit to anything. Now that I've set up and checked all the inputs and outputs, and yes, there were a lot of them, it's time to quickly check over the car and get ready for the first startup. Well, here we are, moment of truth. This is the bit that every wiring guy frets. So Davo's spent so much time wiring this car up, but then it's always something that you've missed or something you're not quite sure. We've gone through and we've pinned everything out, so we've double checked all the wiring, we've double checked all the current control out of all the PDM channels. We've already used a timing light to synchronize the ECU timing with the engine timing, using the lock timing stuff, using a timing light on the crankshaft. Being an engine that's got a very specific trigger type that's not movable anyway, we already knew our TDC offset angles and that sort of stuff from previous experience with the VR engine. One of the things I didn't mention before is that the starter motor on this engine is actually controlled through the NEXUS series ECU as well. So we've got a high current output that goes to the solenoid on the starter motor itself. Then the start-stop button is tied to that output through the ECU. If the car's in gear, or if you don't have your foot on the brake, the thing won't fire the starter motor. The starter motor is going to turn on up until we reach 250 engine RPM, then it'll turn off after that, or it'll time out after 3 seconds if the engine doesn't start and run. So all that's left to do, foot on a brake, we're definitely in neutral, start. Oil pressure's good, fuel pressure's good. Just going to let it run for a couple of seconds. Oil pressure, fuel pressure. Mixtures are looking good. Wow. Oh, it's been a bit of an adventure getting here. It's been a big wire up on this car, but it started, it had good oil pressure. Fuel pressure stayed solid. We're running about 50 pounds of base fuel pressure on this thing. Our air temp and coolant temp are both displaying sort of 18 and 20 degrees, so haven't moved that much. But now the thing started just for a couple of seconds, so now it's time to get under it, check for leaks, check for anything that sort of looks a bit funny, and then after that, I'll start it and warm it up, get it up to operating temperature, then go through and do the same checks again. Once we're happy with how the car is mechanically, it's going to start to get to the exciting part. We're going to move across into the dyno room. I'll go through, I'm going to tune the engine, I'm going to do the closed loop boost control, I'm going to do the closed loop flat shifting stuff on the dyno, but that then does need to be tidied up on the racetrack because we don't have the inertia of the car on the dyno that we do at the racetrack. So that'll be a whole bunch of fun on the flat shifting stuff. Just doing the normal engine tuning, doing the variable cam control. Still a lot of work to do before we get the song on the racetrack, but I'm super excited, and I can't wait to see you guys in the next adventure.